Hello everybody, this is Ice, and welcome back to another video in my Let's Program series in which we create awesome stuff for my Ice 100 Redstone computer. Now, what can I say? A regular, normal show type series just cannot survive my upload schedule. I can't do it. So you'll get episodes when you get them. I'm just not even going to try to do them regularly anymore. I hope you don't mind, because it's just, I can't do it. I'm sorry. It's my schedule. But anyways, without further ado, let's get on with the actual programming. Now today we are going to be creating an addition program, similar to the one that was originally programmed with the computer. Now, what you're going to have to first do is get rid of all of the torches on these wires. So just start nabbing them off like this. And once you're done with that, you can get back to me and we will start the program. Alright, so the last wire should be around here that you have to take torches off of. Not too bad. But now let's get started. So, first thing is you have no idea how this whole thing works. What are these different colors? What does it all mean? Well, that's what we're going to go through before we even think about creating a program. First of all, these colors on the wires are red, blue, green, and yellow. And just if you want to see where they are to find them in the computer, if we come back here, you'll see that they're right down here in the middle of here. This is where you program them. Now, first of all, the program is executed on all of these 64 redstone wires in these 4 layers. It will go the program starts here and goes all the way back. Then it will come back to here, this wire, and go all the way back, then to here and all the way back, and finally to there. The very last instruction the computer can take is right here, just as a notice. But that's pretty much that. Now, like I said, we have 4 colors here. They are red, blue, green, and yellow. We won't be worrying about yellow in this tutorial, so I'm not even going to tell you what it does. We're going to be talking about these first 3 in this video. The first set of 4 wires is red. Red represents the command. So for instance, red will tell the computer whether you want to add 2 numbers, or I don't know, get a random number or get a user input. All of that is decided by this red part here. Blue and green are both the arguments. And we'll talk about those a bit later as we get more complex with the computer, but without further ado, let's just start coding. So the first command in this computer is the INP command. The command code for this command is simply 0110. In binary, this means 6. Now input will basically take an input from the user with that submit button we saw earlier in the last episode of Let's Program, and puts it into a register. Now, the only argument it uses is arg2, which basically tells you what register it will put the input to. Now, when we code our commands onto the actual computer, it will be a little bit different because the numbers are reversed, but we'll talk about that when it happens. With that out of the way, let's actually use the command. So, what we're going to do is to actually put a command into the computer. All you have to do is go into this side of the wire and put a torch here. Now, as we saw, the command for user input is 0, 1, 1, 0. Now, it actually starts here, so it would actually be 0, 1, 1, 0, meaning that this is 6, and this means that it will go in and tell the computer that we want to get a user input. Now we are... Oops. Sorry about that, that shouldn't have happened. But we already know that this will get a user input. And we know that the arguments say that this will mean it will save a user input to the register 0, because there's no arguments anyway. Now, as we also talked about, this also requires a wait command after that. So that's what we're going to do. We're going to put 0, 1, 1, 1, like this. And now, that is our wait command, and like I said, this doesn't have any arguments either. So now that will get one of our user inputs. For the other user input, it's very similar. We're going to use the same command here. So, a user input But now we want to save the second input somewhere else because this first spot is already taken. We can't use it again. So we're going to go into our arguments, completely skip over this blue argument and go straight to the green. And then we're simply going to put in a 1. So like this. 1 or 0, 0, 1. Like that. And that represents 1. And as you might have guessed, we're just going to put in another wait command after that. Now the wait command after the input always has to have the same arguments, so we're just going to put that argument back on there. And now we've gotten all the input we need for the program. Our next command is the ElReg command. This is command 0001, which is of course backwards on the actual program memory, but it is command 001 for the computer. Now, ElReg, basically what it does is it takes data from one of our general registers, which we've already talked about, and puts it into a main register. Now that sounds kind of complicated, but basically it just moves our data around the computer. Now we'll talk about how to use this in our program in just a short moment. So, as we just saw, the next step is to put our data into the ALU registers. So, for the next command, we're going to move the 0 input, which we already got back there, into our ALU register 0. Now, this requires no arguments. Now, we're going to come and do the same command here on this red, which is 0, 0, 0, 1. We're going to come over here, and now we need to save the input 1 that we created back at the beginning of the program to register 1, which is the other ALU register. And that will prepare the two numbers to be added together. So we're just going to put a torch on both of these blocks here, and that will signify that we're moving register 1, which is our second input, into ALU 1, which is the other input to our ALU, which we'll talk about right about our next command, which is the ALU command. Now, this is a hugely important command. It's very important. Basically, what it does is it is what does all of the math and logic in the computer. Now, this is command code 0101, again backwards on the real program memory. And basically, the arguments are first the function, so what the ALU is going to be doing, and second, the register the ALU will save to. So let's get using that in our program. So I understand we've been doing a lot of command showcases, but as we learn more and more commands, those will become more and more infrequent, and eventually we'll just stop doing them altogether, especially when we get into the really big game programming stuffs. So what we're going to do is, on this line here, we're going to put an ALU command. So what you're going to do is you're simply going to put down 0, 1, 0, 1. And this represents our ALU command. And that's that. Now, the first argument for our ALU command is the function, which we talked about. Now, this is function 0, so we're going to leave that alone. The second argument is the place to save the ALU output to. And since we don't care about our inputs anymore, we'll just overwrite register 0. Or the general register 0, anyway. Now, the final step in our ALU adding program is simple. Extremely simple. All we have to do is move our ALU's output, which we already have, into the register that will put it on our number output. Let's just quickly set the time today, and then we can do that. Basically, for this, we're going to move our ALU output into a register. So, we're going to put down our ElReg command, which we just talked about. And now, we're going to move register 0, or our general register 0, since, of course, we don't need it. That's where our ALU output is, into main register 3. So you're going to put 0, 1, 1 for 3. And main register 3 is basically the register, it's pretty important, that holds the number output. Now finally, on the next line, you're just going to turn on all 4 red wires, and this will turn off the computer. But now, that's pretty much it. your program should look something like this. And now, let's actually go up to the control room and give this a tester. Now, if you watched this far, I want to thank you for doing that. That's great. And I also would like some feedback from you. Leave it in the comments below. But basically, do you like how I did this video? Is it too fast for you? Does it not make sense? Or is it too slow and you're kind of dragging along like, yep, I already know this? Just leave that feedback in the comments and I will change based on that feedback. But anyway, I think it's about time to run the program. So let's turn the computer on. And the first thing we see, luckily, is our user input light turning on. So let's add, I don't know, 27 plus 62, because why not? 27 in binary is, this looks like this, like so. And then you're going to press your submit button. And it should now turn on again, asking for our second user input. That's beautiful. So we're going to input 62, which is actually a lot of stuff. Looks like that. Is that correct? Let me think. It should be. If it's not, well, we'll know. Now we're going to hit our submit button, and now we shouldn't have any other input checks or any of that. It should just calculate our answer, give us our output, and then turn the computer off. So let's see what happens. This kind of takes a while because it's a redstone computer. It's not fast in any way. And as you can see, we have gotten the answer of 89. And 62 plus 27 is indeed 89. That's pretty awesome. Alright, so the computer even turns itself off for you so you don't get any unneeded lag, because it's quite a laggy device, as you might expect. Now, before we go, I just want to address one problem. Maybe I shouldn't have worded it as a problem, but more of just a simple thing. If your program didn't work, if I was too fast or something, or you misread it, or misheard the video, I'm not going to make you go back and rewatch it to find your error. Instead, for every episode where we create a program, I'm going to leave that program in a pastebin document below. You can go out and check that out, and it will tell you everything you need to know about the program. It will tell you how to code it and all that stuff. But that's pretty much what I have for today. If you enjoyed the video, please leave a like, as this was kind of a new thing for me, teaching you how to program on a redstone computer. You probably felt pretty awesome doing it. But there you go. Hope you enjoyed, and as always, well, bye now.